Modular exponentiation is when you find the remainder of something, of a number raised to a very large power when divided by some other sort of large number. So, for instance, what remainder do you get when you divide 42 to the 50th power by 71? So it's some number less than 70. But if you try to work out 42 to the 50th power on your calculator, it's be a really large number. So there's a shortcut that enables us to answer this question without a very powerful calculator and only requiring a few multiplications and divisions. And here's the way it works. I'm going to make a chart starting with 42 to the first power. 42 to the first power is just 42, even if you divide by 71 and take the remainder. Anything less than 71, that will be true for. The next thing on our chart will be 42 squared. Now 42 squared is 1,764, and when you divide that by 71, you get 24 remainder 60. So 60 is the number here. And we're making progress, but to get to 50, it seems like we're going to have to go do this 50 times, but we don't, because there's a little trick. We can double the exponent to 42 to the fourth. Now, 42 squared is 42 to the fourth. So that means we could take the answer we just got, which was 60, and just square that. So 60 squared is a lot better than 42 to the fourth power. 60 squared is 3,600. And when you divide that by 71, you actually get 50 remainder 50, which is a little confusing, but it means the remainder of 42 to the fourth mod 71 is 50. Now we could really start saving time, because the next thing we can do, 42 to the fourth squared is 42 to the eighth, and since I know 42 to the fourth gave me 50, I can just do 50 squared, which is 2,500. 2,500 divided by 71 is 35, remainder 15. I can now jump to 42 to the 16th power just by doing 15 squared, which is 225. 225 divided by 71 is just 3, remainder 12. And finally, to the 32nd power is just 42 to the 16th squared, which is 12 squared, which is 144. 144, that's pretty close to 71. It just goes in 2 times, which gives me remainder 2. Now, don't need to go any further, because the next one will be 64, which is already bigger than 50. And here comes the sneaky trick. 42 to the 50, we find the numbers that add up to 50 on this list, which is just 32, 16, and 2. So we write 32 plus 16 plus 2. We can now split this up to 42 to the 32nd times 42 to the 16 times 42 squared. Normally we go in the other direction. We have a bunch of expressions like this and we combine them. Here we have an exponent that's got pluses in it. We can split it up into multiplying. Now 42 to the 32nd, according to this last row, is 2. And 42 to the 16th is 12. And 42 to the 2nd is 60. So I multiply those two numbers together, those three numbers, sorry, to get 1440. Whoops. And when I divide that by 71, I get 20, remainder 20, which is also confusing. But 20 is the answer, the remainder. And 20 is the value of 42 to the 50th power mod 71. You could always find powers of 2 that add up to any number, so there's not going to be a problem there. This process is always going to go very fast because of the way the exponents double each time, and that's how you raise something to a power and mod without using large numbers.